Welcome everyone to another exciting episode of FiST Chat, your podcast that features discussions on the topics of film, science and technology. My name is Ben Warner and I'm joined once again by my good friend and colleague Steve Kern as we clock up our 80th episode. It's been great getting here and I'm glad that we actually made it all the way here.
It's fantastic, Ben. It's a big journey, almost as big a journey as what Curiosity has made today.
Absolutely, and we're all Mars curious today after the events that have occurred on that red planet. But just before we get into that, our usual housekeeping, don't forget our website, www.fistchat.com. Get all our links there, interact with us on Facebook and Twitter, get all our back episodes on YouTube and Vimeo and Digicosm TV. Subscribe to us on iTunes, RSS Audio and FeedBurner. And you can also check out our weekly blogs that we keep pumping through on a weekly basis. And just thought I'd mention now, I'm also writing for bitrebels.com, a tech website in the US. So you'll be probably seeing a couple of those pop up on our social media channels from time to time.
Excellent. Well done, Ben. Well done.
Thank you, Steve. Now, just before we get stuck into our curious Mars topic here, just a little coda from last week where we talked about social media in the Olympics. Came across an interesting little nugget where apparently NBC in America are showing, they're doing delayed telecasts because of the time difference. And the problem here is that the news is all over social media. So what's the point of watching the telecast?
I sort of have a memory that this kind of happened to them last time. I can't believe they've done it again.
Well, I mean, it's just madness. And maybe they needed something like this to happen in order to say, well, maybe next time we won't do this.
Well, maybe next time they won't. I mean, I think, look, as we spoke about last week, by next time the athletes will be broadcasting themselves and there won't be any need for NBC.
And hopefully it'll all be on demand and we can choose whatever we want to watch.
Exactly.
All right, so let's move on to our main topic, the Mars Curiosity and its touchdown. We're there only a couple of hours ago, as I understand.
Yeah, around 3:30 Australian Eastern Standard Time. Curiosity touched down on Mars, and this is big, Ben. This is big news. Curiosity is a big rover. I mean, it's almost the size of a small car, and it's certainly much larger than the rovers up there already. And now for the next year, it's going to be Mars uncovered.
Absolutely. I can imagine if it was that size that they must have been quite worried about how they were actually going to get it onto the surface too without any issues.
Well, that's right. Not since the Viking landers, which were pretty much like the Apollo mission Eagles that touched down in the 70s, have they tried this on Mars. And the reason that they've gone to sort of a controlled descent is because the previous Mars missions, they used the big inflatable balls and tried to get them actually to ditch and roll once they hit the surface. And what was happening was they were losing a couple of them. And so they've gone for this. And this is just amazing. I mean, this is a big, heavy object that's been parachuted and then, rocketed into place. Perfectly. That's an amazing achievement.
It's a testament to all of NASA's abilities, really, isn't it?
It is, and you have to remember that these calculations are done in advance and then all automated because it's about 12, 13 minutes time difference between a signal from Earth to Mars. So they basically have to leave it up to the lander. The NASA guys do all the calculations, do all the simulations, do all the testing, then they send the instructions. And if something, is wrong in those instructions, they don't get a second chance because the Curiosity itself is in charge of its own landing.
And it boggles the mind about if you're working on a team that produces a vehicle like that, how much detail you have to cover, how every eventuality, every possibility that you have to cover, it really boggles the mind.
Look, that's why it takes years to create a mission like this. And for anyone who watched the live stream on NASA TV, which is an awesome live stream and some of the best television that you can see, especially when it comes to space, you will see how many people they've got working on that descent process. And they have everything covered. You know, they've got literally hundreds of people that you can see there in the room and in the back rooms that make sure a mission like this is a success. And it's fantastic to see in there men and women of all ages and, you know, just working for that goal. It's brilliant.
Absolutely. If we move on to the Curiosity itself, is this, in a sense, it's building upon what's already been happening as far as other probes that have gone there? I've just had a look up on the Discovery site, and they're saying it's going to look for environments where life could have taken hold and been preserved. So in a sense, it's sort of looking for life, but it's more looking for evidence that life had been there before. Well,
that's right. We doubt, or I don't know if I can speak on behalf of NASA or the astrobiologists. It's unlikely that there's life on Mars at the moment. There may be traces of life in the subsurface, so just beneath the soil. The actual Martian surface is really inhospitable, but it's possible that just a few inches below the topsoil there may be life or the precursors for life. And we sense now that Mars had running water on it millions of years ago, and may have had a climate existing long enough maybe for the precursors of life to have started. So we don't know what we'll find there. The Curiosity itself is a rover. It's much larger than the Spirit and Opportunity that have been there already. It's also a mobile laboratory, proper mobile laboratory. It can dig down into the soil. It can sample the soil. It can search for things. This is big.
Yeah, absolutely. So just from a technological point of view, then it's obviously been designed to last for quite a while on the surface to be able to do all of this stuff?
Well, at least a year. They're saying a year. The experiments they've got currently planned for it are a year's worth. But I guess if, like Spirit and Opportunity, Curiosity keeps going, then it's possible, that maybe you get 2 years and they'll be able to do things that, they haven't planned for yet. And that's likely, and that's very exciting too.
Is there any chance then that they might be able to perhaps get some more data back or evidence of how an eventual, say, manned mission to Mars might work, give them more information to work with and that sort of thing?
Well, that's definitely what they're working on. I mean, they've got the Mars orbiter around now, which basically maps Mars's weather patterns. Mars has got a atmosphere of almost 100% CO2. But the thing about Mars is that the atmosphere there is only about 1/100th of the density that it is on Earth. So it's a very, very thin atmosphere, which is why it's so cold and very inhospitable. But, there are now that they've got the aerial views of Mars, and people can go online at the NASA website and see evidence of mountain ranges that may have been shaped by running water. So there's, when Curiosity starts digging and searching and looking around there with the best equipment that we've ever had to explore another world. I mean, this beats anything that we've ever, really sent anywhere else in the solar system. This could really unearth some really big questions and maybe even give us a few answers along the way.
Absolutely. Mars has always been a fascinating place to go, and I guess it's sort of a logical next place to go since the moon, for all intents and purposes, has been covered over the past 50 years. So that is the natural next place to go, and it'll be amazing to see how this mission adds to the sort of further exploration of Mars and, our eventual travel there, which I'm sure, if we're lucky enough, we'll see it in our lifetime. And then maybe if you're lucky enough, you'll get your dream to go there too, Steve.
Maybe. I mean, this is the thing, today it's a big step for us to go to Mars, but in reality, it's just a small, small step for humans to achieve that next step, because it doesn't matter who you are, what you believe in, what colour, what religion, what politics you have. It is unquestionably true that for the human race, the next step is space.
Enough said. And as long as we don't destroy the planet as we're leaving.
I think that's why we're going to have to head into space.
All righty. Well, let's move on to our news bites, which are all related to, which is quite cool. We always like it when that happens.
Yeah.
Now, Total Recall is being released as a remake in Hollywood. Unfortunately, this one doesn't feature Mars, but for those of you who remember the 1990 movie with good old Arnie.
My favourite Arnie film.
Absolutely. It's a really intelligent sort of Arnie film, isn't it, by comparison?
Well, it was written by Philip K. Dick, so maybe...
that's right, it had to be. But it's amazing. I was just reminiscing on that film in preparation for this topic today, and there's a lot of very interesting things in there, and it also goes to show that Mars has also been a sort of a setting for a lot of science fiction films over the years. Some good, some not so good. I'd say Total Recall is probably on the top heap of the good ones, but then you got your others like Mission to Mars, Red Planet.
We've covered those in the previous FiST chat, Ben. Under Hollywood disasters, I think.
Yeah, absolutely. So let's hope this. It's hard to say how this new one will turn out, but we can still love the original.
We're only going to love the original. I don't think the new one will be anywhere near as good, but let's just go so far to say that this film may well be prophetic.
Absolutely. Now, science. We've got... geologists at the University of Texas at Austin have examined large-scale polygons on Mars and compared them to similar features on Earth's seafloor, which they believe may have formed via similar processes. And I guess this is what you might have mentioned a little bit before about water being on Mars in the past.
Yes. Yeah, that's right. So, it's really interesting that these comparisons can now be made, and these polygons are done by the Mars orbiter, which is taking featured or big wide shots of the Martian terrain, and it's giving us a view of the Martian surface like we've never seen it before. And what Curiosity will be able to do is just dig that little bit beneath the surface and find out what's beneath that red soil. Is it frozen? Is it water? What sort of minerals are there? Are the building blocks for life there, Ben? Because if they are, what does that mean for us on Earth?
Absolutely.
Prometheus.
So we don't have to travel as far as the crew of Prometheus did to find out where we came from. We just have to hop to our neighbouring planet.
Could be, Ben. Could be.
Absolutely. All right, and lastly, technology-wise, now apparently when the Curiosity landed, New Yorkers had the chance to see it on the big screen in Times Square, which was kind of nice of New York to do that. And again, you mentioned before about NASA's television coverage, which was being broadcast live in Times Square. And I guess that's the amazing thing in this day and age with all the technology that's available to broadcast things in so many different mediums that, back when, humans landed on the moon, there was just the one point of being able to watch that, and that was a marvel in itself, being able to see that. But now this is just everywhere, and as you mentioned, I think just before we got on, this has been tweeted to the hilt. NASA's website's crashed, because of getting images from so this is the other thing, live images from the actual rover itself. It's just amazing that all of this comes together, and you can pick and choose where you want to get your feed from when things like this happen.
Well, I think, space exploration, at least in public opinion and the public's mind, might have been in the doldrums for the last 40 years since the moon and the mid-70s. But, now with this media, now it's accessible. Now you can go online, you can look at pictures of the Hubble that the Hubble's taking. You can watch the transit of Venus, see a solar eclipse, and now you can see what's going on live on Mars. If this isn't enough to excite the public, and I think it will, it's the technology that we have today that is helping us appreciate this, helping us get excited about it. And this is exactly what is going to get us all into space, Ben. All into space. We're going to be working on the moon, living on satellites, and flying back and forth between Mars, just for a commute.
And that's a short-term future we can all look forward to, isn't it?
Let's hope so.
Absolutely. All right, we're out of time, so thanks again, Steve, for the chat.
A pleasure. Hello to everyone on Mars.
Absolutely, and they can tweet us too if they like. All right, so that's it for this week's episode, so we'll catch you next week.